So I've been using the React compiler pretty much in all of my projects ever since it came out in beta just a couple months ago. And for the most part, I didn't really run into any problems. I mean, the compiler is kind of advertised as something that you just install and set up in your project, and then you forget about it. You never have to think about memoization ever again, right? I mean, before it was called the React compiler, it was called React Forget. But recently, as I was working on my secret project, which by the way, waitlist is open, first link in the description, I ran into some very interesting performance problems that shouldn't really happen because I was using the React compiler. Essentially, I was having components re-render when they shouldn't because they were supposedly automatically memoized. And actually, it got so bad that it completely crashed my React debugger as I was trying to debug what was actually going on. Now granted, part of that was my fault because I was running this on an AI chat, so every single token I was getting like so many renders, but still, this shouldn't happen because I was using the React compiler. So naturally, I started to do some digging and I went online to try to educate myself on the compiler because there had to be something that I had missed. Otherwise, I wouldn't be having these performance problems. And it turns out that there actually was. What I found is that the React compiler is definitely not something that you can just install in your project and completely forget about memoization, completely forget about use memo and use callback. You still need to know about memoization. And arguably, now that we have the React compiler, you need to understand memoization even more. And in a lot of cases, the React compiler is actually lying to you in terms of what it's making you believe, and it's making you think that you are covered when in fact you are actually not. So yeah, that was a huge rabbit hole. I want to use this video to tell you everything that I found out because this really is important, especially considering the fact that pretty much every single React application moving forward is eventually going to be using the React compiler. Let's get into the video. Alright, let's begin. Now first, I want to give a very big shout out to Nadia Makarevich for this phenomenal article because this is the article that actually made it click for me and made me understand how the React compiler actually worked and what I was doing wrong. She essentially had very similar performance problems with her applications with the React compiler, and she went and did all of the work to try to figure out what is actually going on. Now, we're not going to be reading this article for this video. If you do want to read it, there's going to be a link to it in the description. But what we are going to do is we're going to look at this repository over here. She went ahead and created a repository which has all of the different examples with the compiler and without, so we can actually look at them and understand how this all works and what the problem actually is. So here I have the repository up and running locally on my machine. This is a Next.js application running Next 15 with the React compiler enabled. And here we have 3 links. We're going to go through each one of them one by one. The first one is going to be just to kind of understand how the React compiler actually works using simple examples. We're going to see with and without the compiler. And then these 2 are actually what I want to get to in this video. This contains the actual problem in a real world example and how we can actually fix it. I promise you this is going to be worth your time. You really want to see when we get to these 2 links over here. So let's start and let's go to the first link, which as you can see here will be very slow on initial load because we obviously have some performance problems that we need to take care of. So this is what it's looking like. We have a couple of simple cases here, each one showing something with the compiler and without. Now, before we start interacting with any of these and actually look at the code, it is important for us to see that the compiler is actually working. So for that, I'm going to come here, open up the React DevTools, go here to components, and we should see a tree of all of our components, right? As I scroll down, you're going to see that things are highlighted on the actual screen. And already we can see that the React compiler is in action. You can tell by this memo here with the sparkles. If you hover over this, it's going to say that this component has been auto-memoized by the React compiler, so we know that it's working. If I keep scrolling down here, you're going to see that as we get to our simple cases over here, all of them are pretty much memoized. We have all of these tags over here that says every single component is memoized. So that's good. The compiler, at least at the surface, seems to be actually working in this application. Now let's open up the code and see what we're working with. So I'm going to go here to SRC. I'm going to go here to components and I'm going to go here to simple cases. And these are all of these simple cases that you see on the screen directly. So let's first start with simple case 1, right? So simple case 1 is your traditional expensive component that is unnecessarily re-rendering because the parent component is re-rendering. So right, we have the simple case 1 component here. We have this use no memo directive here at the top, which essentially tells the React compiler to skip memoizing this component, which essentially is as if we did not have the React compiler running in this project. Here we have a state variable is open. right? It can be changed from false to true. And then we have a button here that is actually going to change that variable. If the variable is open, then we're going to show this dialog here. And then we have this very slow component. This very slow component here is purely simulating the actual slowness by just waiting for 300 milliseconds. And then we'll log to the console every single time that this component re-renders. That's how we're going to be able to track if the component is re-rendering or not. So if you come back here to our project, this is the component here. I'm going to open up the console here and just clear everything. And now we're going to press toggle dialog. It's going to take some time, 300 milliseconds. And then we have the dialog here. But importantly, we saw that we had a re-render of the slow component, right? This is nothing new. We've all seen this. This is your classic performance optimization problem in React. Now, in traditional React, if you're not using the React compiler, how would you go about fixing this? Well, we have to go here to simple case one memo. So this one is also using use no memo, so there's no React compiler here. And the only difference that we have here is that this one is memoized manually by using the very slow component memo, which is defined over here by just wrapping that same component in react.memo. This is going to make it so that this component is not going to re-render unless its props actually change, which in this case, because it doesn't have any props that we're passing to it, it should never re-render. So let's see how this is working. I'm going to come here, clear the console, maybe make it a bit smaller. We're going to come here to example one, memoize manually. I'm going to toggle this, and now you're going to see that this is instant, right? I can press this as many times as I want, and it's re-rendering, and it's very simple. And more importantly, we're not getting the expensive re-render inside of our console log, which means that the component is not re-rendering. That's very good. Now, again, this shouldn't surprise you. This is the way that we've been doing things for many, many years before we had the React compiler. But now we have the React compiler, so we theoretically don't need to do this. The React compiler should be able to handle this case automatically for us without us having to wrap anything in memo. Well, let's see. That's exactly what we have in this case over here. Simple case with the compiler. So here we no longer have the use no memo directive here at the top, which means that the compiler is going to automatically memoize this component. And then we have the very same code, but here we're returning the raw non-memoized component directly to see if the compiler will actually do it. So let's see. Let's scroll down here to example with the compiler. Let's clear our console logs. And here I'm going to press, and as you can see, it does. The React compiler is memoizing the component every single time, and we're not getting any console logs, which means that it's doing the same exact thing as we would have done if we wrapped the component in memo. But now, because we're using the compiler, we don't have to do it. This is great. This works. Now let's look at a different example, this time with props, right? Because that was a very simple example. So here we have simple case 2. Once again, we're not memoizing this component. We have the same state variable over here, but now we have a function on submit. And then we have a data array here, which is an array of objects. Both of these are getting passed to the very slow component here as its props. So if we come back here to our application, now you're going to see that as I press, I'm just going to clear this, as I press toggle dialog, now it's slow again, and we're getting the re-render here as well, right? So the memoization is not working, but of course it's not because we disabled it in the component. Now moving on here to simple case 2 memo, this is how we would traditionally memoize this component ourselves. So we would also put use no memo here, and then we would wrap the on submit with a use callback, right? Passing here an empty dependency array because it currently has no dependencies. And for the data object here, we would wrap it in use memo again so that we have stable references across renders. And then we're going to now use the memoized very slow component, and we're going to pass the same props over here. Because we memoized it, and because these props are now stable references, we should not get any new re-renders. And let's see, let's come here, let's clear, and now we're going to toggle the dialog, and it works exactly as we expect. We're not getting any new re-renders, which means that our memoization is working. Again, we've seen this is nothing new. Well, now let's see how the React compiler is handling it. So we have no use no memo at the top. So the compiler is using this, is memoizing this component. We're not wrapping the on submit and the data in any callbacks or any use memo, and we're not using the memo component, and we're passing these properties here directly to it. Let's see if the React compiler can do the job for us. So finally, we're going to come here, clear once again, and we're going to toggle this, and you're going to see that it is fast and we're not getting any re-renders. So yes, it turns out that the React compiler actually works, and for the most part, so far, we just set it up and we didn't configure anything and it automatically did everything for us, and we no longer have to worry about memoization ourselves. Cool. So then what's the problem? Why am I making this video in the first place? Why am I saying that the compiler is lying to you? Well, the truth is these are very simple examples, right? They're simple components, usually isolated components with very simple props, and this is not really representative of a real application, which often has a lot more complex code, a lot more hooks, a lot more functions, a lot more components, and that's where the React compiler actually seems to break down. It doesn't actually, but it seems to. If I go back here to this article, you're going to see that she actually did the work and she tested this on 3 different apps, and these are the results, right? So this first app here is the biggest one, which has around 150k lines of code. So this is actually real code, right? She identified 10 easy to spot cases of unnecessary renders, right? So theoretically, the compiler should be able to fix all of those. So first she did an initial health check, which is basically just an npx package that you can run that basically scans your components, sees which ones can be memoized and which ones can't, and if you have any like incompatible libraries. In this case, she had 97.7% of the components that could be compiled and no incompatible libraries. Perfect. ESLint, just 20 rule violations. That's usually fine. Stuff about React 19, we can ignore that. But then here we go to testing the app. Out of 10 cases of unnecessary re-renders, only 2 were fixed by the compiler. 2 out of 10. What happened? We just saw 2 cases and they both worked. What's different in a real application? She did another test on a second app. This app is much smaller, 30k lines of code, and she identified 10 unnecessary re-renders. Out of those 10, again, only 2 were fixed by the compiler, even if she has still 97.7% of the components that could be compiled. Once again, what's going on? And finally, app 3 over here, this one is a very small application. She found 8 unnecessary renders. Initial health check said that 100% of the components could be compiled, so that's great. And out of the 8 cases, only 1 was compiled. So right, this is surprising, and odds are if you now go and implement React compiler in your own project, you're going to get similar results, right? Because chances are that your application is not one simple component with one prop and just doing things very simply. You often have much more complex code, and that's where the React compiler doesn't work exactly as you would expect. So why? Why doesn't the React compiler work? Why does it only do 1 out of 8 or 2 out of 10 in most applications? Well, let's find out. Well, let's now go to the second link over here and let's see what we have. Now, this is a very simple country list application over here. This is meant to mimic a real world application. We're using a couple of hooks that you would typically use in your applications. And let's see how this actually works and how the compiler is doing with an application that is a little bit more real. Now for that, we're going to come here and open up the React DevTools again. We're going to go here to components. We're going to press this cogwheel over here and we're going to toggle highlight updates when components re-render. What this is going to do is this is going to make updates. Actually, I should have the console open. This is going to make updates visually on our screen as we're doing things. We're going to see exactly which components we render, right? So here we have countries broken. That's a component. We have our table and all of these components. They're all re-rendering every single time that I type something on this input. This is going to be useful because we can then compare this to the compiler and see how it is different. So that's actually the first problem over here, right? This one, every single time that I'm typing on this input, every single thing re-renders here, including all the individual row components here, which really they shouldn't because this is bad for performance. So let's see the code and let's see why this is happening. So this is the countries broken component over here, and let's see what we have. So here we have a state value here, which is a string. This is the actual value of our input. Then we have this query client over here because we are using useQuery. Then we're running a query here to actually get the countries. This is, I believe, just returning a static list of countries. Yeah, these are the countries here. Then we have our delete country mutation using use mutation, and then on success, we're just going to manually set the query data using the query key. Again, pretty standard. We have a onDelete function here, which will call the delete country mutation. And this one, important, is not wrapped in use callback, right? So there's no manual memoization going there. Same thing we have here for the add country mutation, another mutation, and another function to add the country that is wrapping the mutation and then setting the value here to an empty string. The body of the component is a bunch of JSX over here, a header and a paragraph tag. Then we have this table component here, which I believe is some, yeah, it's ShadCN, right? So we have the ShadCN table component here. here. We have the caption, we have the header, we have the table body, and then inside of the table body, we're mapping over the countries and rendering a row for each individual country. And finally, we have here this input button here at the top with a button that we can actually type and add a new country. So this is very representative of a real-world application component. It is simple, but it's just complex enough that we can actually see some real-world examples with the React compiler, right? Oftentimes, you have a query, you have a mutation, maybe you have multiple queries, multiple mutations, you have a bunch of different functions in your component, and then you have a lot of JSX here, and you're mapping over things, you're rendering different parts of it, right? This is very representative of something that is a real application. Now, what's going on here? Because we saw the code, right? And if you go back here to our components and actually scroll down here, we're going to see that all of these components here are memoized, right? If I can just scroll down a bit to get to the actual rows themselves, here we have table row USA. This is memoized. We have table cell, right? This is also memoized. If I scroll down here, all of these table rows here are memoized. The components within them are memoized as well. But if I come here and I type something, all of these table rows here, the table cell, they're all re-rendering. So what's happening? Is the compiler lying to us? Well, to understand that and to really see what is going on, we have to actually do the work and memoize the component ourselves to actually see what the React compiler is doing. Because the React compiler behind the scenes is doing the memoization for you. So if we do it ourselves, maybe we can get some insight as to what is actually going on. So here we have a component that I just created. We have countries broken manual memoization, right? So this is a manual memoization of the same component. So this state variable doesn't change. There's nothing that needs to be memoized. This query client here as well. This query doesn't need to be memoized because this data here should be memoized by React query. So you don't have to worry about that. This delete mutation here, again, should be memoized by React query, so you don't have to worry about it. But then we have this onDelete function, which we have to manually memoize over here. And we're passing it here the delete country mutation because that's its only dependency here. Same thing for the add country, right? So we're not having to memoize anything here because React query should be memoizing this. Then on add country, we're going to use callback here and then pass the actual value here because we are depending on this. And finally, we have the entire content of previously what was table body here. We have to wrap it in a use memo because again, the compiler is going to do this. All right, so we have the same code here, all of the countries that we're mapping over, each one, it's really the same code. It's just rendering every single row here. And then we're passing countries here and then onDelete. And then here we have the updated JSX. This is still the same. This whole table thing is still the same. What is different is this table body here. We're now using the actual manual memoized component because again, the compiler would do this. And then we're passing it here, the memoized body that we just created using useMemo. Everything is fine, but now we're passing all of these references here, which should be stable references. So actually, let's see how this works. So let me just export it here and let's just remove this manual memoization here and then unexport this one just so that we're using the other component. And let's see how this one behaves here in our application. All right, I need to put some underscore here or something to fix it. There we go. So now we have an error here. Again, we're going to ignore this. This is a hydration error. It doesn't really impact us ourselves. Cool. So now we memoized everything automatically. So now we shouldn't be having any performance problems, any re-renders, right? So let's see. Let me start typing here. And oh, we have the same exact things over here, but we memoize things ourselves. So what's going on? Well, to see what's going on, let's look at our code and let's see, did we forget some dependencies? Did we misconfigure something, right? What could possibly go wrong here? So we have our onDelete function over here. We are wrapping this in use callback, right? And as long as this delete country mutation is stable, this should be fine, right? So we have this delete country mutation. This is coming from a library, so it should be fine, right? And then the same thing we have here for the onAdd country. We're using the same use callback, passing it the add country mutation. This body over here, which is what we're seeing render, right? If I go back to the application, as I type something, we're seeing this table body and the table row re-rendering. So all of this is re-rendering. Well, why is it re-rendering? It has to be because the countries is different, but the countries is purely here a query, so it can't really be different because this is a stable reference from React query. It doesn't really change. But then we have this onDelete over here, which, I mean, that's the only thing that can actually be causing this problem here. This onDelete must be breaking the reference check somehow. Well, the only way that this onDelete could actually be breaking this equality check here is if this delete country mutation wasn't stable, right? That's the only point in our application that something can go wrong. So let's actually go and see the source code of React Query to see if this is actually a stable reference or not. And here I'm just going to go in this article because, again, phenomenal article. Nadia, she did like a really good job, both the article and the repository. She actually ran into this problem and did the work and went and looked at the React Query documentation, the source code rather, to see exactly what's happening. So this is the use mutation hook, right, officially from Tanstack Query, right? So let's see what this is actually returning, right? So here we have the result. That is some result here, which we're not really concerned about. We have this mutate function here, right? That's what we need. We're calling a mutation here. This is wrapped in use callback. Perfect. So it is stable, right? It is memoized. Perfect. But then if you look here, what is returned is an object that is not wrapped in memo, right? It's not memoized. The mutate function is, right? That is a stable reference here because it is wrapped in use callback, but the object itself is not. Which means that what we are returning here, this delete country mutation object, is not memoized. It's not a stable reference. So this will change every single render, which will cause this use callback to get invalidated every single render, which will cause this use memo here to get invalidated every single render. And that's why we're getting all of these renders here. So then what if we come here and we replace this by just accessing the mutate function directly, call this delete country mutation, and then we're going to pass it here and then replace it in the dependency array here by just a direct function which is stable. What is this going to do? Well, let's type now, and now, oh, suddenly nothing is re-rendering. Wow, that was the problem. And so our problem wasn't that the memoization wasn't working. It was that we weren't memoizing it correctly. We were passing an object here that was not a stable reference, and that was breaking the entire memoization across the chain. So now what would happen if we come here to this initial one with the React compiler and did the same exact thing? So if you come here and then use mutate and then pass it here delete country mutation, the same exact thing. Here we just call it directly, right? And that's the only change that we did. Let's come here and let's export this, and then maybe just rename this one as well so we don't have any conflicts whatsoever. Let's come here, let's put an underscore. Now, what happens if we run this code here, right? Now we have done no manual memoization, we just did it through the React compiler. Well, look at that. We have the same exact results. Everything is memoized automatically. Isn't that interesting? So it turns out that the React compiler wasn't actually wrong. It was doing the thing that it was supposed to do. It was the actual memoization, the way that we structured our components, that was wrong. And this really explains why she was having such bad results in real applications, right? Results of like 8 on 2 problems out of 10 being resolved, right? And then like 1 out of 8 even. It was because of the way that the code itself was structured. So the problem isn't the React compiler. The problem is the code that we write. And as you can see here, we will only able to understand this by actually doing the manual work of memoization ourselves. So using the React compiler properly requires us to understand memoization and how it works, because we need to understand it for us to write the code, for it to be able to do its job properly. This is very interesting. Now our code here, although it fixed this part, it still doesn't fix when we add something, everything re-renders. When we delete something, everything re-renders. We're not going to go into that because it's more of the same, right? It's more of the actual memoization code that we wrote that was bad, and the React compiler had no choice but to re-render things because we weren't structuring and passing things properly. If we go back here to this last URL here, this is with everything fixed. This is what it looks like when you kind of fix everything, and we're going to look at the code in just a moment. Here we have no problem if we're actually typing something. When we add something, not much is re-rendering, but as you saw, the individual table rows are still re-rendering. And then if we press delete, again, they are re-rendering. They shouldn't technically re-render because nothing in the individual row changes. But again, we're going to look at what she had to say in this article and also my own experience in my own project. So if you go here and we open up this countries fixed component, this is what it finally looks like. So what she did is she had to extract this country row in a separate component. The reason she had to do that is she was having some trouble with getting this to actually not re-render. And as we've seen, this actually did re-render every single time that we added or deleted a new row. So even this isn't fully 100% working. Then in the actual component, we have the same state, the same query client, the same queries here. So this, good to know, this is always going to be stable because we're accessing it directly using the data property. But if we weren't, then this would actually not be stable, because I'm pretty sure that this is not a stable reference, the entire object that is being returned from use query. The mutation here is the same thing. We're not wrapping it in any callback. The add country is the same thing. And then the JSX here, the only thing that we're doing is we're passing it the countries here. We're just mapping over a separate component. That's the only thing that we did. But even with this, as you can see, we delete something, the table row is still re-rendering. And she says it here in this article that she wasn't able to actually figure out the solution, and that she's out of ideas on how to fix it with the compiler, and that it's also enough material for the article already, right? So fair enough, she wasn't able to figure this out. And to be very honest, I also wasn't able to figure out one minor thing in my own project. And this is a bit unfortunate, because there seems to still be some uncertainty on how the compiler actually works. And maybe that's why it's still in beta. And maybe when it gets fully released as an official version, then maybe this will no longer be a problem, and we'll finally be able to have a solution to this last mini country row re-render. But don't let this discourage you. This is eventually going to be fixed, right? And for my case, I actually had to manually wrap a component in memo, because the memoization that the compiler was actually doing was not enough for my specific use case. Now, granted, I didn't look through all of my code, which I probably should do now that I have a good understanding of all of this here. And I'm pretty sure that I returned the object in multiple places, so maybe that's kind of one of the issues. But I think that would involve a lot of refactoring, which I don't really want to do right now, because I fixed my performance problems by just altering all the other smaller things that I could have done, and then just putting that small memo that just wraps that one component to basically prevent it from excessively re-rendering. But still, all that put aside, if you're using the React compiler in your application, be very careful, because things are not exactly what they seem, right? Again, if I go here to this broken one, right, and I think we memoized it, so it wouldn't really work. But if you go here and you see all of these memo things, it's very easy to think that you have no problems, that everything is automatically memoized. That's why the title of this video is how the React compiler is actually lying to you, because this is not always true. And you need to understand memoization now more than ever to make sure that you actually make this be true, because the React compiler is not magic. It's just a tool that does the work automatically for you, but you still have to set everything else up correctly for it to be able to do that. So yeah, what's the verdict? The verdict is that the React compiler is good, and you could technically just enable it, because it does just work, right? We saw it just memoizes everything, but you cannot forget about memo, use memo, and use callback, and you have to know them better before using it. This was a phenomenal article. Shout out once again, really, I mean this, to Nadia for writing this article for the repository. This was super great, super insightful. I learned a ton, and I hope that you have as well. That's it. That's all that I have for you in this video. If you've enjoyed this video, make sure to leave it a big thumbs up. You can also click here to subscribe, or click here to watch a different video of mine. My name has been Eris Kozin. This is Kozin Solutions. Thank you so much for watching, and I will catch you in the next one. Ciao, ciao.